Internet pornography is consumed by millions of people every day, almost exclusively in total privacy. Because of this isolation, we rarely see exactly what is happening to the human body in real time while those pixels flicker on the screen. To measure that hidden biological toll, a recent study gathered two very specific groups of young adults. Group A consisted of 16 healthy, casual viewers. Group B was a smaller cohort of 5 individuals who reported severe, high-frequency addiction to internet pornography. Before looking at any screens, researchers needed to establish a cognitive baseline. They had everyone take the Stroop task, a classic psychological test where you have to identify the color of a word while ignoring the text itself. It is a proven, reliable way to measure focus and reaction time. At minute 0, the results were entirely normal. The casual viewers and the high-frequency viewers scored roughly the same in both cognitive accuracy and speed. Next, the researchers wired everyone up. They attached facial recognition cameras and heart monitors to track external life signs. To look inside the skull, they used fNIRS brain scanners. This diagram maps out exactly where those sensors were placed across the scalp to track real-time blood flow and oxygen levels in specific regions of the brain. With a solid baseline of normal cognitive function established, the researchers had set a trap. Any physical spikes, drops, or delays recorded over the next few minutes would isolate the exact biological cost of viewing the content. The researchers pressed play on a 10-minute pornographic video. Almost instantly, the physiological reactions of the two test groups split in completely different directions. These bar graphs track facial expressions during the viewing. Blue bars for Group A show clear spikes in surprise and disgust. Red bars for Group B tell a different story. High-frequency viewers registered dominant levels of vacant, neutral expressions, mixed with a numb, passive happiness. Their cardiovascular data was counterintuitive. This line graph illustrates their real-time heart rhythm. Instead of a racing pulse, the heart rates for Group B dropped. Their parasympathetic nervous systems kicked into overdrive, forcing a heavy state of physical calm. To understand why a highly stimulating video was causing heart rates to fall and faces to go blank, the researchers had to pull the fNRS data and look at the brain's internal network. These brain maps display the functional connectivity happening inside the subject's skulls. In Group B, you can see a massive clustering of active nodes. There is explosive, rapid-fire communication happening in their prefrontal cortex, specifically the dorsolateral and frontopolar regions. Those regions are tied directly to the brain's reward system. The intense clustering means their neural pathways are being flooded with dopamine and heavily overloaded by the digital stimulus. While casual viewers show standard arousal, the high-frequency group experiences a systemic biological overload. The data shows their nervous system being forced into an unnatural, suppressed state. As the researchers reviewed this highly specific cluster of physical symptoms, they recognized a pattern: a plummeting heart rate, a vacant, euphoric facial expression, intense physical calmness paired with a hyper-connected prefrontal cortex. That exact combination of symptoms perfectly matches the known neurobiological footprint of opioid drug abuse. The human body processes chronic pornography consumption as a heavy narcotic hit, mirroring the exact neurochemistry of clinical intoxication. At the 10-minute mark, the monitors went dark. This timeline graphic shows the next immediate step of the experiment. Researchers forced the participants to retake the exact same cognitive test from their baseline. Group A picked up right where they left off. The casual viewers easily navigated the word puzzles, maintaining their accuracy and keeping their speed up. But these bar charts map out the post-viewing scores for Group B. Their ability to process the conflicting colors and words completely fell apart. Their accuracy plummeted and their reaction times spiked significantly compared to their own baseline scores from just 10 minutes earlier. That sharp decline is the mechanical result of the crash. The excessive neural connections that flared up during the video created a short-term cognitive traffic jam. The reward circuitry was so overloaded that the brain struggled to perform basic executive functions, resulting in immediate brain fog. The researchers found that this friction bleeds into daily life. Before the experiment, all participants filled out psychological surveys. Group B scored significantly higher on scales measuring generalized anxiety and depression. It creates a closed loop. The temporary opioid-like numbness they seek out to alleviate anxiety directly causes the cognitive fog. That mental bottleneck makes daily life harder to manage, generating more of the emotional distress they were trying to escape in the first place. This study proves that pornography addiction causes a physical rewiring of the brain. Because the damage is biological, meaningful recovery requires addressing the condition as a severe physical dependency.